Today, our topic is about the measures of central tendency. Before going through this topic, let us go through some characteristics of the data, or we can say the properties of the data. First, the data is having the center. What lies in the middle of the data set is at a center. Second is the variation. Data is having the variation from the center, if having any variation or not. And third, it's the distribution, if our data set is normally distributed or not normally distributed. Mm, it's outlier is the data value that lies outside the data, or it is the data value that lies far away from the center. And the last one is our data set changes over the time. For suppose I have collected the data last year, and this year I am collecting the data from the same subjects or same respondents. The last year's data and this year's data, there will be some changes, so data changes over the time. Now, the measures of the central tendency. Measurement provides quantitative description of people, events, and objects. The numbers are assigned as per the rule. After the assignment of the numbers, the individual score is compared with the average to know the position in the group. The point which represents the average of the group is known as the central tendency. Okay, it is the point which represents the whole of the distribution. Okay, now, the measures of central tendency are of three common ways. First is mean, which is also known as the average or the arithmetic mean or arithmetic average. Second is median, and the last one is mode. We will go through them one by one, but in today's lecture, we will only explain how to calculate the mean. The mean of the distribution is known as the arithmetic mean. As I have told you, mean is the average value. It indicates the average of the group. So the arithmetic mean is the sum of the scores divided by the number of the scores. It may be defined as the point on the scale of the measurement obtained by dividing sum of all the scores divided by the number of scores. Mean is calculated as we have two types of the data sets, ungrouped data and the grouped data. Mean is calculated from the two types of the data, that's ungrouped data and the grouped data. Let us take first the ungrouped data. As you know, what's ungrouped data? In previous lecture, I have told you that ungrouped data is one which is in mess form and which is not in organized form. Okay. Here is the formula for the ungrouped data. This is mu. This is known as mu. It is the symbol for the population mean. When we have collected the data from the population, whole population, then this formula is used to get the mean of that data. Mu is the population mean. This is the summation of the x. X is the observations, and n is the number of the observations in that particular population. Okay. This formula and this formula have no difference. Only the difference lies in the symbols. X bar is the symbol for the sample. When we have collected the data from the sample, we we have the symbol X bar, and when we collect it from population, we have the symbol mu. So X bar is the sample mean, and this is the summation of the observations in, and this is the number of the observations in the sample. Let's take an example. Suppose I have 9 students in the class, and I have tested them, and I have collected the test scores as here. I have the 9 students in the class, so it's the population. Only 9 students are there. So the number of my this population, size of the population is 9, and let us have the formula which is mu is equal to summation of x. Summation of x means sum of all observations, that is 2 plus 4 plus 5 plus 6 plus 10 plus 12 plus 13 plus 20 plus 23 divided by number of observations, which is 9. And let us calculate this as 95 divided by 9, and mu will be equal to 10.5. That means the average score of the candidates has remained at the 10.5. Let's take a next example. Suppose I have collected the I have collected the data from the sample. So my sample size was only 5. I have collected that. I have 9 candidates. I have collected only data from 5 students. Okay, then the n will be equal to 5, and the formula for the sample is x bar is equal to summation of the all observations, that is 8 plus 7 plus 6 plus 5 plus 9, divided by number of observations, that is 5, and go on calculating, that is 35.5, 35 divided by 5, and that will be equal to 7. That means this, or this, in this example the mean score has remained at the 7. I hope you have got this. This is simple. Now let us have the mean of the grouped data. Mean of the grouped data, there are two formulas to calculate the mean of the grouped data. One is known as the long cut formula, and another is known as the shortcut formula. This is the long cut formula. Only the difference is this is used for the population, to depict the population, and this is used for to depict the sample. The x mu and x bar is the mean, and this symbol is the summation of frequency, and this is the midpoint of each class. You know that what is the midpoint is upper limit plus lower limit divided by 2, and n and this n is the population size, and this n is the sample size. It is the sum of the frequencies, and you know that sum of the frequencies is equal to the number of observations always. And the shortcut formula, it's also known as assumed mean formula. We assume first mean and then apply this formula. When we assume mean, then after that, this is, if the population, that this will be the symbol, and if the sample, this will be the symbol. M is the assumed mean, and F is the frequency. What's this x dash? X dash is the deviation from the midpoint, deviation of midpoint from the assumed mean, and this is the summation of fx dash, and n will be, if the capital N, then the population; if the small n, then the sample, and I is the size of the class interval. Let's go through some examples. Here's another example. Suppose we have collected the data, okay, and this is ungrouped data, but how to make it grouped data is to make a frequency distribution table. Pause the video and make it in the grouped data. Make the frequency distribution of this data. I have made the frequency distribution. Go through the last video and check how to make the frequency distribution table. Here I have made the class intervals, and next I have tried the frequencies. In first class 20 to 24, there is only one observation in this, so the frequency of it is 1. And in second class 25 to 29, there are 1 and 2 observations, and the frequency is 2. And in 30 to 34, there are 1, 2 and 3 observations, so the 3, 4 and 5 observations, there are 5, the frequency is 5. And in 35 to 39, there are 1, 2 and 3, so the frequency is 3. And in last class there are 4 observations, so the frequency is 4. And the total number of observations is 15, and so is the sum of the frequencies, it's 15. Okay, now the formula, this is the long cut formula, this is mean, and this is f is the frequency what we have, and x is the midpoint. The formula, for the formula we have to find the midpoint of each class. How we find the midpoint? 24 plus 20 divided by 2, it is 22, and same 25 plus 29 divided by 2, it will be 27. To keep in mind, not to exercise so much, to keep in mind, we have, if we have the class intervals in increasing order, then we have to find the midpoint of first class interval, then go on adding the size of the class interval. What is here the size? 25 minus 20 will be equal to 5, or 29 minus 24 will be equal to 25. When we have 22 midpoint of first class interval, then add the class size, that is 25. 22 plus 5 will be equal to 27, and 27 plus 5 will be equal to 32. 32 plus 5 will be equal to 37, and 37 plus 5 will be equal to 42. One of the two methods you can apply, okay, which is convenient for you. Next, what we have to find the fx, f multiplied by x. This is f is 1 in first class and x is 22. That is x 1 multiplied by 22 is 22, 2 multiplied by 27 is 54, 5 multiplied by 32 is 160, and 3 multiplied by 37 is 111, and 4 multiplied by 42 is 118. Then we have to sum this column. Summation of fx, we have to sum this column. It will be equal to 115. Okay, so we have summation of fx which is equal to 115, and we need n which is equal to 15. Applying these values in the formula, this will be equal to x bar will be equal to, this is equal to 115 divided by n is equal to 15. Okay, then calculate this. The mean will be equal to 34.33. The mean score is the 34.33. Okay, let us take same example and calculate with the shortcut formula. Shortcut formula is assumed mean formula. For we have first to depict the assumed mean. For having the assumed mean, we have to have the midpoint of the class intervals. To calculate the midpoint, like I have already told you how to calculate the midpoint, these are the midpoints of the class intervals. Okay, so after calculating the midpoint, we have to take the assumed mean. You can take any midpoint as the assumed mean, but for convenience we take the assumed mean as the midpoint of the class interval which lies at the center of the series. Okay, if the series is of odd like 3, 5, 7, then we have no problem to have the assumed mean up at the center. Okay, if it is in even like 4, 6, 8, then there will be two classes at the center. If there are two classes at the center, go for the assumed mean one which is having the highest frequency. Okay, here we have the odd number of the classes, so the assumed mean will be 32, two upper and two lower, and this is the 32. Okay, now we have to find the deviation from the assumed mean. To find the deviation from the assumed mean, we have to subtract the midpoint from the assumed mean and divide it by the size of the class interval. I is the size of the class interval. Here the size of the class interval is 5. 25 minus 20 is 5. So calculate each class this deviation, assumed mean deviation. Okay, the first class, this is 22 minus 22 minus 32 is assumed mean divided by 5. It will be equal to minus 10 divided by 5, and which is equal to minus 2. And in second, it will be equal to 27 minus 32 divided by 5. It is minus 1. In third, it will be equal to 0. 32 minus 32 will be equal to 0. Anything divided by 0 is equal to 0. And next will be 37 minus 32 divided by 5. It will be 5 divided by 5, and it will be equal to 1 plus 1. And next will be equal to plus 2. Keep it in mind, if the class intervals are in increasing order, then the assumed mean is having the zero deviation. Then from the above side of the assumed mean, there will be the negative deviations. We write minus 1, minus 2, minus 3 up to what class. And from the lower side of this assumed mean, there will be the positive deviation. If this is in decreasing order, suppose this class will be here and this class will be here. The bigger class will be at the top, and this smaller class will be at the bottom. Okay, then the assumed mean, the deviations from the assumed mean, the upper side is having the positive deviations and the lower side will be having the negative deviations. I hope you have got this. And then from the formula, we have to depict the f into x dash. That means uh, multiplication of frequencies and deviations from the midpoints. Okay, this is the 1 is the frequency, and it has the deviation minus 2. This is minus 2, and 2 is the frequency, deviation is minus 1. This is 1. 2 into minus 1 is minus 2. 5 into 0 is 0. Anything multiplied by 0 or divided by 0 is equal to 0. 3 into 1 is 3, and 4 into 2 is 8. Okay, From the formula, it is summation of fx dash. So we have to sum this column. Sum the negative observations. It is -2 plus -2, it will be -4, and it will be 3 plus 8, it will be 11. 11 minus 4 will be equal to 7. Go through these calculations. Okay, then we have here the assumed mean is 32, what we have assumed, and summation of fx dash is 7, and number of observations is 15, and the size of the class interval is 5. Let us give it these in formula. X bar is 32 plus this is 7. It is 7 divided by, and n is 15, and I is 5. Okay, this is 5 ones, and 5 ones are 5, and 5 threes are 15. This will be equal to 32 plus 7 divided by 3, and this will be equal to 32 plus 22.33, and this will be equal to 34.33. So as you have seen in the shortcut formula, there is also the mean is 32.33, and in the long cut formula the mean remained the same. If you have not done any mistake, then both the formulas should give the same mean. For you, I hope you have got this, and for this I have kept the exercise. To find the mean of the following data using the both methods, that means the shortcut method, this is the grouper data, and you have to find the mean by the shortcut method and the logcut method of these, and give me your answers in the comments section. Okay, I hope you have got this. Till I will be with the next video. Till then, stay home, stay safe.